building big one. Sealing around the edges with isopropanol. It is possible to eliminate scattered light with a ruler. It gets difficult to seal around the edges and needs some weight to put on top. Temperature is too low and vapor is too dense. Good start. Now it becomes too cold and we lose the nice tracks. Thermocouple with super glue. To cool down large plate, which would be good for video filming, but can reach only minus 19 degrees and there are no tracks. A way to measure temperature with a thermocouple at minus 20 degrees centigrade. First tracks start to appear. Now we have nice tracks at minus 21. The thermocouple, it disturbs the tracks, but temperature is minus 24. 93 millimeters diameter alu plate. Socks. C'est beautiful. Tracks appear in very narrow region. Here everything is already condensed on the bottom plate. Then we go higher with the beam of light. Temperature minus 22 degrees centigrade. Completely happy because the screw head places are visible. I opened the chamber and blew air into it, and looks like concentration of vapor decreased and tracks became more pronounced. Strange effect: when there is water, ice on the cold surface, droplets fall down and still remain droplets on the cold surface for a couple of seconds. Uranium containing glass. Tracks can be long and also short if comes from inside the glass, and sometimes is radon, but not very often. Tungsten welding rod containing 2% thorium. We see alpha particles coming out. Quantum energy medallion. Quantum energy medallion. A rock from Iterby mine. Rock from Iterby mine through glass wall, no effect. Americium through glass wall. Sometimes see small specks, which are gamma quanta being absorbed by the gas and ionized. Americium in the chamber saturates the vapor. Americium through a plastic, we get some puffs which are from X-rays, ionization from X-rays. Americium, beryllium and plastic, 2 weak source. Americium, beryllium, silver, plastic. Tritium light bulb, do not see any effect. Airplane switch in the chamber. silica gel bag which was in the jar with radium switch. Sealed the edges with water. I found optimum surface area of the sponge for present conditions. Don't get over saturation. Iteration with the fan worked very well. Now LED is not hot anymore. LED has a fan and 3D printed round adapter which transforms into a rectangular slit 5mm wide, and it's very bright. Home built LEDs were not as bright as the torch, so the tracks were not impressive. Modification with high voltage electrode outside the dome. When it is high above, we see many tracks simultaneously because they collect ions from large volume, and if I lower it down, then we will see fewer tracks. A sock can be folded to adjust the area of evaporation. The setup is plastic tower, had to put electrode inside, otherwise the tracks became erratic after an hour or so. Filming through the top. With the big container, feeling is that there is no wall. The big plastic container can get conditions that do not see any reflections from glass. And the tracks are sharp. Have voltage connected to the wet towel. Now there is no scattered light. Felt from matte, it's more thick and needs a lot of isopropanol to saturate, comparing to kitchen towel. Magnets are sewed with a needle and thread. Now we have practically no problems with the scattered light, and the top plate should be thin. Great thing is that since we don't hit the walls with the light, we don't care about the cleaning of the dome. Put black felt carpet on the top. It looks very thick and needs a lot of alcohol to saturate the felt. Filming video through a peephole. Filming through a peephole, windowless video.